So today we are going to talk about our best practices in gain structure. So this comes from a quantum series little class that we had put together, but we want to go through it a little bit, uh, mostly because uh, gain structure really is the foundation for any audio system. So, we talk a lot of times when we're talking about, either audio signals or video signals that you're only going to get out of the far end what you put into it in on the input side. So we really do want to make sure that the way we are setting up the audio chain in our digital processor is done in accordance with what we call best practices. Now, the reason we call this best practices and not rules that will fit 100% of the time is because, well, there are no rules that fit 100% of the time. If I told you that method A is the way to do it, then I guarantee you someone will come up with a use case where maybe method A is not exactly the best way to do it. So we just call this best practices. This is going to kind of go through and show you how to lay out your system from input to output to give yourself the best chance for success. Okay, so let's talk a little bit about some terminology that we're going to use today. The first thing we want to talk about is the noise floor. So in any digital signal processor, there is going to be noise that is just generated from the electronic circuits. Excuse me. The other thing that we want to talk about is the clipping point. So when we talk about a clipping point, we talk about what is the maximum amount of signal that we can put through. In this case, in the case of a Q-SYS DSP, this is going to be plus 24 dBu. A dBu is a little bit different than a dB in that, well, we'll cover that here in just a second. However, let's just talk about, so our noise floor is the base level. This is the amount of signal that we're going to have with just nothing connected. And then our clipping point, that is the maximum. That is where we are actually, clipping off the top of our signal. And everything that's left in between is our dynamic range. So when we start to talk about headroom, and when we start to talk about, our signal to noise ratio. So when we talk about let's talk about our nominal level first. So this is sort of our sweet spot. This is where we're ideally looking to have our signal. In professional audio, this is about plus 4 dBu on a line level signal. So this now gives us two more terms to use, which is our SNR. So this is our signal to noise ratio. This is how much above the noise floor is our signal. This definitely comes into play when we start talking about things like, AEC processing and things like that. Your signal to noise ratio will become very important. And then headroom is how much room do we have between our nominal level and our clipping point. So this is just the amount of room we have to work with, just in case we get a louder signal due to some volume fluctuations. Okay, let's talk about preamp circuits. So this is what happens when we bring an analog signal into a digital processor. What we have going on here is you bring in the signal, it's analog. We then have an analog preamp, and then we will hit what is called the ADC, or the analog to digital converter. So this is where this is where we first make the change from the analog signal into the digital domain. Now, once we have done that, we also have some digital gain that we can work with. So when we're coming in, when you're setting up a Q-SYS input block, you will see some analog adjustments as well as some digital adjustments. So let's talk about this analog to digital conversion. When you are in Q-SYS, you will notice that we switch to using, we go from dBu into DBFS. So DBFS is decibels full scale. This is where we sort of recalibrate what we're looking at in terms of our signal levels. So where we were in DBU, we just, we noticed that we had a plus 24 was our clipping point. Well, when we get into DBFS, then 0 DBFS becomes our clipping point, and then we work relative to that. So earlier we talked about having a +4 nominal level and a +24 clip. Well, once we switch into DBFS, now we have a 0 DBFS as our clipping point, and -20 DBFS becomes our nominal level. So when you are looking at your input block in the DSP, we are not, as is done with some of the other DSPs on the market, you are not looking for 0. What you are looking for is -20. So as you can see on this little screen grab on the right, because we want to have our 20 dB of headroom on the input circuit, so we need to be able to leave that room. And if 0 is our clipping point, then -20 is where we want to have our nominal level. And we want to go through every single input, and we want to make sure that everything is evened out on the input side. So you can also see on here that we have analog adjustments. So that's what's highlighted in red. This is where you will make these adjustments to get yourself to -20 DBFS. But then there is also an area there for doing some digital adjustments. But it is the preamp gain in the analog space where you want to achieve your -20 DBFS. Now, we've been talking about line levels. Yes, so the question is -20 for digital inputs and analog. Yes, you want to have -20 DBFS across the board for everything. The blocks look a little different when you're talking about the Dante input blocks or the AES67 input blocks or the QLAN input blocks, whatever it is that you may also have going on. But yes, you are trying to achieve input parity at -20 DBFS for every input coming into your system. Okay. So let's talk about microphones. Microphones are a little bit different in that they're going to have their own noise floor because they are picking up noise in the room. So when we look at the AVIXA standards for speech intelligibility, that references a 15 dB signal to noise ratio. So when you are setting up a microphone, you want to adjust your preamp gain until you get to your -20 DBFS, just like we did with our line level signals. And then you will, there we go. Then you will be able to work with your signal to noise ratio. So when you set your input, if you say, I have a noise floor, like in this example right here, you have talked on the microphone and you are getting yourself to negative 20 DBFS. But when you stop talking on the microphone, you're looking to see what the ambient noise floor is in that room. In this example, there is a noise floor of negative 31. So based on our 15 dB SNR that we are looking to achieve, this would not meet our microphone intelligibility standards. So what we would really need to happen is we need to find a way to decrease our room noise. So same thing, that you are, when you stop talking, we are now below negative 35, meaning that we have more than 15 dB. Please explain where we can see when we've achieved negative 20 dBFS. Okay, so this is it right here. So this is on your mic line input block. Depending on which processor it is that you're using will be how many of these you have available. But you will adjust this preamp gain until this meter sits on average at 20 and a half. Not 20 and a half, on negative 20. Someone else put it in here that they were having some audio dropout from me. Is everyone experiencing this, or is it just one person? I'll wait a moment. Good, good, good. Okay. Well, then my apologies to anonymous attendee. I mean, I am using a quality Q-SYS NMT1 microphone and running this through a Q-SYS processor. So, I mean, it really couldn't be me, could it? Thank you, Matt Jones, for the 5x5. I love a good old radio reference there. Unless, of course, you also happen to be a Buffy the Vampire Slayer fan, and then I will also accept 5x5. Okay, moving along before I go down a rabbit hole. All right, so in our microphone, we have, thank you, God, Brian, that really made my day that you said 5x5B. One of my best friends and I, we say that to each other all the time. I will be calling him later to make sure that he knows that we are not the only two giant nerds in the world. Thank you. That really made my day. Okay, so we've gotten our microphone. When we talk in it, we get negative 20 dBFS. When we stop talking, it drops below negative 35. Now we have our 15 dB of signal to noise ratio, and we have now met our AVIXA standards for speech intelligibility. So let's talk a little bit about a microphone signal path. For any of you that really want to go even deeper into a lot of these blocks, there is another class that I have taught that is called dynamic audio processing, where we go over things like compressors, limiters, expanders, gates, automatic gain control, continuous ambient compensation, things like that. So, excuse me. We're going to just discuss these blocks a little bit, but we're not going to go crazy deep into them, just because it really all depends on what your situation is, how you should set these. But let's just talk about these blocks, and these are the ones that we are generally going to use. High pass, low pass, parametric will generally go in every microphone chain. How you put them in that order is not critical. What we're trying to do is we're trying to cut off any super low frequencies. So that's what our high pass is going to do. It is going to pass through high filters and cut off the low ones. this will help keep out a lot of your low end rumble noise, like air conditioners and a truck driving by. It'll help keep some of that from getting picked up in the microphones. Low pass is going to do the same thing, only it's going to let low frequencies in. So basically with the high pass and the low pass, we're just cutting ourselves a little notch in the middle of frequencies that we want to allow to pass. Typically, you're going to set this on the higher end. It's really just to make sure that, again, super high pitch frequencies don't get passed through the microphone. And then the parametric is just there to catch whatever else we need. If we need to boost the mids a little bit, or if we're catching feedback, somewhere on our low mids, we can pull that down a little bit. So when you buy a microphone, generally that microphone manufacturer will provide you with a response plot, and that will tell you how the microphone responds across the frequency spectrum. And you can use this to then adjust your parametric up or down based on how the microphone performs. So if I've got a microphone and the manufacturer tells me that, at 5K, they have a little bump in their frequency response, well, I may want to pull down my 5K in my parametric just to flatten that out. Otherwise, I might find myself with a whole lot of sibilance in my talking, in my presenter. So this is a good chart to use when you are trying to hone in on intelligibility. It is not universal, because obviously some people have deeper voices like I do, some people have higher voices. So you want to, if you're struggling hearing people's vowels, if you're struggling hearing their consonants or their sibilants, which are those S's and T's and Z's, these are just some frequencies where you can start to try to boost or, cut off a little bit to make sure that it sounds very smooth when they talk. Let's talk about dealing with feedback. So when you are setting up a system, we have a block that is called a notch feedback controller. Generally, the way we recommend setting these up, because these are kind of processor hogs, is that you would just put one of them in a file and then use your signal probe to run through it. If you are just using it to commission a system, you can put the notch feedback controller in line, do the commissioning, and then go offline, delete the notch feedback controller, and then repush your file so that you're not using all of those resources all of the time. So what this is this is actually, I believe, from level 2, where we do this as an example, where we put the notch feedback controller in, we put a microphone right next to a speaker, we do a couple of settings, and what you end up with is, this is the inside of the notch feedback controller. And once it starts to detect feedback, you will see it pulling down those frequencies. And what we can do is we can then say, okay, well, obviously we've got hot spots from 150 to 210, and then from 600 to 800. And now we can go into our parametric EQ that we have in chain before that notch feedback controller. Then we can pull those down and clear the dynamic in the notch feedback controller, and then run it again until we are not getting feedback through that channel. Okay, once we have gone through with the notch feedback controller, The next thing that we want to talk about is using mixers. So we have two different types of mixers. There are matrix mixers, which are very simple, couple of inputs, couple of outputs, route them, move on. And then we have auto mixers. So auto mixers run generally as multiple inputs to a single output. You can also enable them with their own outputs, but generally they're going to be a mixdown type. And we will use some automation to determine which mics will pass to the outputs. So let's talk about matrix mixers first. So matrix mixers have input controls and output controls. Those are overall. They also have crosspoint controls. So this is where you can either mute an input going to an output, or you can change the level of how much of that input do you send to a particular output. We use these a lot in conferencing systems to create our AEC reference chain. So we will run all of the microphones and the USB and soft phones, all of that stuff into a matrix mixer. And then on the output side, we will create different signal paths for the far end for our conferencing, the speakers we have in the room, and then we'll have one dedicated for our AEC reference. And the reason we do that is so that we can create different gain structured signal paths for these uses. So this can become very helpful, because if you are, for whatever reason, say your AEC is having a hard time converging, so you're noticing that you're just not getting a very good AEC reference signal, but it sounds fine in the room. You're getting plenty of volume in the room, you're getting plenty of volume to your far end, all of that is fine. Having a matrix mixer in there means that you can go through and just make adjustments to those inputs that are getting fed to your AEC reference, and you can adjust that gain structure just for that signal path. So matrix mixers are super handy. The one thing to remember about matrix mixers is that they come born with all of their cross points at -100, meaning that nothing will get out. So you do have to, once you go live, you have to either emulate or push the file and open the block and set those to, 0 is pass through, -100 is off. So you will have to set them all to whatever you want them to be before it will start to work. Okay, auto mixers. This is generally used for your conferencing and speech reinforcement. What is really cool about these, typically what you will see is us using these gating automatic mic mixers or auto mixers. What this does is, say we've got 8 microphones in a room, and we only want to make sure that at any given time, excuse me, the people on the far end are not hearing every single microphone open all the time. So what we'll do is we will set a nom, which is the number of open mics. We will generally set this from 1 to 3. Any more than 3, you are just asking to have a whole bunch of extra noise come into your signal path. So let's say we've got our 8 people sitting around, and I'm having a discussion with someone else. If we have a nom of 3, both of our mics are going to come up. Not a problem. That's only 2. Somebody else wants to chime in and put in their 2 cents. Fine. We're still at 3. Once you start to get into just full bore arguments where you've got 5 and 7 people trying to talk at the exact same time, nobody really wants to hear that anyway. So by setting your number of open mics to, 2 or 3, 3 is generally the sweet spot. You can make sure that you don't have to hear all of that going on. It will take the strongest of the signals and make sure that those are the ones that pass. When you are dealing with either recording scenarios or conferencing scenarios, we always recommend that you leave the last mic on. The reason for that is if you turn that feature off and no one is talking in the room, people on the far end may think they got disconnected because they will just literally hear nothing coming through. So if you leave the last mic on, then at least one mic will be open, and the people that are on the far end, or if you're doing a recording or something like that, it'll at least sound like there's still something going on. However, if that is not something that you want to happen, then by all means, turn it off. That's why it's an option. Okay, so let's look inside of our gating automatic mic mixer. So when only one person is talking, we are not doing any attenuation. It is just 1-to-1. Once we have a second person talking, because you will notice on the right-hand side under number of open mics that we have a non-attenuation step. So what that means is that for every microphone that we open, or rather every time we double the number of mics that are open, we are going to attenuate all of them 3 dB. So when I go from 1 mic to 2 mics, I go down to -3 dB. When I go from 2 mics to 4 mics, I go to -6 dB. So what this is doing is this is just keeping, as a bunch of people start talking, it keeps it from just getting louder and louder. So we're just going to say, well, we've got this many mics that are open. We're just going to go ahead and pad this just a little bit. The other side of this is a gain sharing mixer. So this is a gating mixer that we've been dealing with. This is a gain sharing mixer. What this is basically all microphones have a maximum gain of 0. If you're not talking on them, we reduce their gain. And then as people start talking, they get gain back. These are less common for being used in like conferencing systems. However, there are always times when you may want to use a gain sharing instead of a gating. So now you can see your gain sharing as people start talking, they're getting some more of the gain. This is generally, like I said, this is generally used when you're talking about large microphone systems. So most of what you will probably come across while you're dealing with conference rooms and whatnot will deal with gating auto mixers. Okay, so let us look at what we have talked about so far. So there are plenty of times, and this is absolutely considered best practice to have both matrix and auto mixers in the same signal flow. We do this a lot with our sample designs, where we've got a whole bunch of microphones, we process them, we run all of those into a mic mixer, and then we run everything else into a matrix mixer. Again, this is what I was talking about earlier, where we've got some program audio as well as some microphone audio. The mics all get mixed down. We mix in our program audio on the backside, and now we're creating 4 unique outputs. In this case, we've got our 2 speakers, and then a distributed speaker mix, and then an output to a recorder or a far end. Okay, let's talk a little bit about these dynamic blocks. We're not going to go crazy deep dive on them. There's a whole class for that if you really want to go nutso on compressors and limiters and whatnot. A lot of times you will see compressors used, either compressors or automatic gain controls. So compressors are generally used if you feel like you're going to have somebody that's going to get really loud. These are used a lot in performance, but less often in spoken. So you don't see a lot of this done with conferencing. Automatic gain control is generally what you're going to use because what compressors are going to do is once a signal gets above a certain level, it's going to squash it back down. Automatic gain control, you're going to set a target level, and then you're going to say, okay, well, I want you to be able to give me X amount of gain up or turn it down if the person is really high. So generally, a well-crafted automatic gain control will help you with the differentiation between, if I'm talking on a mic and I've got this kind of big loud voice, and then I hand it to someone who has, maybe a little bit of a higher pitched voice that's not as loud. The automatic gain control is, the ticket to help you kind of smooth that out a little bit. It just takes some time to be able to dial that in. Okay. The one thing that we see a lot, so we have to point this out, never place a gate in front of an auto mixer. We see people do this all the time where they've got some kind of noise on the line and they feel like this is going to solve it. It really won't. All it's going to do is really mess up the algorithm inside the gating mic mixer. If you've got noise on the line where this is where people are trying to manufacture their signal to noise ratio. Basically, they've got a really high noise floor, so they're trying to cut that out instead of addressing the issue inside the room. Let's see. Question here is Q-SYS looking into speech detection versus non-speech within AGC blocks, similar to Preamps AGC. Not that I'm aware of. However, this is a good time to plug communities as a great place to go in and put feature requests because the product managers look there, and it always means more coming from users in the field than it does from me. So developers.qsc.com is a great place to go and put any feature requests that you may have. All right, and that's answered. Okay, so yeah, do not place a gate in front of an auto mixer. It will just lead to chaos. So let's talk about adding in some AEC. So I'm not going to spend a ton of time on AEC because A, there are entire classes for it, and B, it can take a while to go through it. So let's just talk about some of the terminology. So when we talk about latency, this is the amount of time it takes to remove the signal. Tail length, this is how long the algorithm will look for echo. We generally start at 200 milliseconds. You can turn it down to 100 or up all the way to 400. However, just know the longer the tail length, the more DSP resources you're taking. So if a core says that it will do 8 channels of AEC, that means 8 channels of AEC at 200 milliseconds. If you turn them all up to 400, then all you're going to get is 4 channels because you are consuming twice the DSP resource by going from 200 to 400 milliseconds. So what is AEC? So what we're doing is we are taking a signal that is coming out of a loudspeaker and we are filtering that out of the microphone. The difference is what we call the RMLR, or the reference to microphone level ratio. So if we are sending a 20 dB reference into our AEC algorithm, and we're only getting 30 in from the microphone, then we have a 10 dB RMLR. So we have a couple of things that we can do. We have some residual echo suppression. This just helps us with rooms that are particularly difficult to get through. Voice lift. This is generally tricky because you are trying to put the microphones from the room into the room and sending them to the far end, which gets a little difficult to then filter out. And then there is mix minus. So if I've got 4 speaker stations in a room, and I have a mic over here and a mic over here, let's say I want this microphone to only play over here, and I want this person's microphone to only play over here. That is called mix minus. It's basically saying I have microphones in the room, but it's not going to come out everywhere. It's just going to come out in areas farther away from the actual microphone. So generally what we're going to do is we are going to bring in our system, bring in our microphones. We're going to run that through our AEC, put all of those then through the mic mixer and send those to the far end. As far as our near end goes, we're going to have our program sources as well as our input from our conferencing system. And we're going to create our AEC reference and then send that to our output in the room. If you need to do some dynamic processing, that needs to happen after the AEC block. So if you're going to do any high pass, low pass, parametric, compressing, all of that kind of stuff, generally you want that to go after the AEC. The reason for that is we need for the AEC reference, or the AEC block needs to hear directly what's coming in off the microphone. And we also want to make sure that our reference is hearing exactly what is coming out of the speakers. So do not put dynamics or nonlinear objects ahead of the AEC. So let's talk a little bit about our reference. The reference is, in the most basic sense, whatever is coming out of your speakers is what needs to go to your reference. Obviously this is when there's no voice lift, and you always want to make sure that you do not put a mic into its own reference. That will sound really weird, and you will know. So let's see. In your example, the far end would not be able to hear if someone played a video on a laptop in a presentation. So we'll talk about that a little bit. So we're talking about when we want to make sure we're putting program sources in, especially if they're getting routed to the far end. So yes, if you are playing something off a laptop in the room and you want to send that to the far end, then yes, you also need to make sure that that is going through your AEC, just so it doesn't get picked up and sent back through the system. Okay, so we are going to assume that we have our gain structure set up on the input side. Again, we want to make sure that we are at -20 DBFS with all of our inputs. This includes our far end. And now we can go through and tune our AEC. So we can go through with our noise reduction. This is going to be some steady state noise. We can also check our RMLR. So when the far end is talking, this should be green, and you should be getting close to that target of 0 dB. You can adjust that reference gain input or that reference gain slider to get yourself closer to that 0 dB target. The adaptive filter. So what this is going to do is, one of the things that we recommend when you're doing AEC is that if you need to mute the microphone, do that after the AEC. The reason is that if you mute the microphone before the AEC, so if you actually mute it in the actual microphone, the AEC will lose its convergence because it can't hear anymore. So if that is something that you absolutely have to do, then you are going to want to set this level just a few dB below the noise floor when it's unmuted. And what that'll do is when you mute that microphone and the input drops all the way to negative 100, it will keep all of the convergence on the adaptive filters. And then when you unmute it and start talking again, you're at least starting from there, and you don't have to wait for the entire algorithm to reconverge. The best practice from our side is to mute the microphone after the AEC. If you need to put a microphone mute button, just put that in the DSP and use that so that the AEC algorithm is constantly hearing and will stay converged at all times. So residual echo suppression. This is if you are having trouble and you're still getting just little shades of echo on the back. You can turn this up a little bit. You can turn it on and then turn it up. Just understand that the closer you get to 100% of residual echo suppression, the closer you are getting to essentially a half duplex signal, meaning that only one person can talk at a time. So be very careful with that. What if there is still significant echo? Check your routing and then check it again, because 99 times out of 100, something is getting misrouted. Mute your microphones. Make sure that it really is echo that you're getting. If you have two mics in a room that are pretty close to each other and you do not set up your gating auto mixer properly, you can actually get coupling where the sound gets to one microphone and then slightly later the sound gets to the next microphone, but it gets past both. And that's not actually echo, that's coupling. It may sound like echo, but it really isn't. So just make sure that you're not having issues with that. The very last thing that you can try is to extend your tail lengths. That is sort of the last ditch effort, but it might be required. We generally just want to tell people to try to mechanically reduce the reflectivity of the room. All right, so once we do this, we will go through and do test calls. When you're doing a test call, if you have multiple codecs or ways of coming into the system, if you've got a soft phone and an MTR or whatever it is, do a test call with every one of them and make sure that everything is good. Once you have gotten past this, or once you've gotten beyond the matrix mixer and you're in the room, most people will like to put a little EQ and a limiter on the far end or on the back end before their line outputs. The EQ is typically going to be for the speaker. When you use Q-SYS speakers, so say you've got an AD-C6T that's in the room, you can just take the block that's in the inventory and put that either in line or if you're using a Q-SYS amplifier, you can put it on the back side, and that will do intrinsic correction, which will do things like limiting and EQ and just sort of help flatten it out. Otherwise, you're going to put an EQ in just to handle the characteristics of the room. So this is what I was talking about. If you're using a Q-SYS block, you can put that in line. There's a property where you can change that to be in line. And then you can put that on a line output. Otherwise, you can just use a regular EQ and set it how you want it. Will a recording of this be available? Yes, it will. Within the next 5 to 7 days, you should receive an email from our marketing team with a recording of this and a copy of the slide deck for your, just endless enjoyment. All right. Let's see. Would you see a use for AEC in live events if you've got a talking head on stage, no actual far end, just using AEC to mitigate room echoes coming back into a lav on stage? I mean, I did a lot of live back in the day, and I would say just be very careful with having them stay behind the stacks and keep them out of their own monitors. But I don't know that I would go so far as to use AEC in a big live production environment like that. Okay, we're almost done. Excuse me. So let's look at the output limiting. The peak limiter, this is basically going to be our catch-all on the back end. We generally will use this if we're using the analog outputs. Again, if you want to get super into the weeds on this, the dynamic audio processing class goes way into when to use these and how to use them and all of that. But generally speaking, we're going to say, just for an example, that we want a threshold of negative or of 0. Actually, we would typically set our threshold at like -3 or so. Really what this is saying is any signal that comes in above -3, we want to just lop that off the top so that we don't damage anything on the output side of our analog feed. So as you can see, as the signal gets above our threshold, we apply negative gain. But understand that we are also clipping our output. So 0 dB cuts it a bit too close. So let's reduce our threshold to -3. This gives us a little bit more margin before we start to clip. So this is what we consider our best practice for setting up limiters on the backside. If we are using QSC amplifiers and we have our QSC speakers, then when we put the block on the backside of it, that will automatically set our limiters. So you can go through and you can see, are we hitting the limiter? Are we into protect? All of those things. However, if we are still using our analog, we want to make sure that we are still trying to stay away from our -0 stay away, from our 0 DBFS. We don't want to just be cramming, 0 DBFS out of the output. So you can use this on the line out. So now we are on our digital to analog converter. We can use this to make sure that we're not just hammering the output to whatever it is that we have coming out. This example, we're looking at a piece of professional equipment. However, if we were using, say, some sort of a consumer line level piece of gear, then we need to be even lower on the output on that. And that's where we'll want to adjust our output gain on the analog side. Sometimes you must feed a microphone level device. That is super rare, but just make sure that you're not getting phantom power coming on it. Okay, so when we talk about this, we talk about output gain structure. So professional line level, that's plus 24 dBu. Consumer line level is negative 10. And then microphones are negative 40. Really, it just means that if you are trying to feed something that is coming in at mic level, you are going to have a much smaller signal to noise ratio to work with. So when you can, please use professional line level equipment if you're using anything line level at all. All right, so let's review. Input calibration, negative 20 DBFS. That's for everything across the board. Put in some microphone EQ just to help clean that up on the input side. Dynamics. So this is going to be your parametrics and your compressors or limiters or anything. Put in some automixers. Use the fewest user gain controls possible to get the job done. This, excuse me. This combined with the idea of only giving people enough throw in a gain knob that they need will save you a lot of headaches on the back end. All right, output limiting. Make sure you do some of that. And output calibration based on which piece of equipment you are using if it is analog. Okay, this class is worth a half a VIXA credit. So you can go to qsc.com/gain structure. Again, you will get all of this in a follow-up email. You can take the little quiz and get your half RU. We also have a little gain structure thing that you can download from there. But I will take a few minutes to answer your burning questions on gain structure. Unless, of course, I just did such a phenomenal job that no one has any questions about anything ever in life. Man. You're welcome, Chris. All right, well, I will stick around for another minute or two. Oh, hang on, here comes my question. While negative 20 DBFS is supposed to be the target level, it seems a range of negative 18 to negative 12 is more commonly used in practice. Why is that? So negative 20 is, again, a target. However, as people keep talking, obviously everything bounces around. So what you will see is that a lot of people will shoot for a range that's like negative 12 to negative 18. Even though that's starting to get a little high. So I would generally say you have the headroom. That's why we say negative 20 is the target. If you need to set up a scenario where one source needs to be a little bit louder than the other, then you can certainly get there. I don't know that I would want to have my entire chain gain structure hinged on an input that was creeping towards negative 10 DBFS. That's just me. Hang on, I gotta clear through some of these. Why are lavalier mics so difficult to EQ, and do you have any tips? Yes, don't use lavalier microphones. If anyone ever asked me, they would ban them from production. They are so difficult to EQ because they have to be able to pick up way farther away than a mic element should ever be from a person's face. It's headsets or nothing. Can you address how pure digital inputs and outputs relate to the Q-SYS gain paradigm? Yeah, same thing applies. When you get into the Dante or the AES 67 blocks, you're still looking to achieve your negative 20 DBFS. I will say, I mean, the reason we call this best practices instead of hard and fast rules is because there will always be scenarios whereby you feel like you need to, stray from these. So, if you get yourself into a scenario where you feel like, I've got everything laid out at parity, but this one input, I just feel like I'm not getting enough out of it. Then yeah, you may have to turn that up and get into a little bit higher area of gain structure. And as long as it's not causing you to clip on the far end or anywhere in your signal, and you'll hear it. If something starts to clip, you will hear it get clipped. You what we're trying to do with this class in a short 1 hour span is arm you with enough information to then go out and make your own decisions. Again, that's why we call it best practices. If you go through and set up a system using these methods, we give you a high chance of success. So with that being said, go out there, tune a system. You still have to use your ears, unfortunately. We can't fix everything. All right. Unless anyone has any other questions, I'm going to cut everyone loose. I hope everyone has a great week. For anybody that is making the trip across the pond next week to ISE in Barcelona, please come by the booth and say hello. I will be out there with a couple of our other compatriots from the US and our European teams and our Asian teams and all of that. So it'll be a really cool experience. Otherwise, we will see you guys next week. Have a great week, everyone.